So I'd now like to demonstrate how to go about implementing the performance threshold-based trigger. So once again, I'll be utilizing a virtual machine for this demonstration. I'll just briefly bring up an administrative command prompt, and we'll go ahead and show the files haven't changed. There is that second data alert command procedure that I'll just type out. Very similar to the first one, except the first thing it does is to disable the task myAlert. So we can start off those performance collectors by start perf logging.cmd. That'll start the perfmon one, and we'll go ahead and start up the etw logging. We can then utilize the logman command to see, yes indeed, the myperf is out there running, and the logman-ets to see that the NT kernel logger is also now running. And if we do a directory, we could see the initial files that it will be collecting data in. So at this point we can go to the alert folder where I have a couple of procedures. I'm going to go ahead and type out the alert task.cmd. This is the procedure that will create the actual scheduled task called myAlert with the corresponding action routine called gatherdataAlert.com. And then it'll go ahead and display that at the end. So let's go ahead and get that one running. And then we'll take a look at the second one, which is the testalertsetup.com. So I'll go ahead and type that out. And so you can see what this one's doing. This one's doing a logman create alert called myCPUAlert, because this time I want to detect if we've got a runaway process or two. And so we're going to be collecting data about the processor time. When it is greater than 50% utilization, I want the system to collect the troubleshooting data and crash the system. You can see here, that's the name of the task, myAlert, that will fire off when that threshold has been experienced. So it has also got a sampling interval of every 5 seconds. So let's go ahead and fire up the test alert procedure, which will start the threshold watching. So anytime the processor gets above 50%, it will then crash the system. So here we go. That's off and running. Now, to give the system a little bit of load, I've got a couple exes. These are just CPU generators. I'm going to type isitme.exe, and I can actually use the start command to put it in the background. So I've got one that is running, and it's churning up CPU time, and I can go ahead and start up a second one too, or not.exe. And so it's now running too. And the system has essentially crashed at this point because it got greater than 50% CPU utilization. So we'll see that it has in fact crashed, and once again we'll just wait for it to reboot and go ahead and log in. So now that the system's rebooted and logged back in, we'll just acknowledge that that crash occurred, and we can bring up a command prompt and take a look at that troubleshooting folder. As you can see, we now have our kernel data that was recorded at 11:54, as was the perfmon data, and we can actually go analyze that crash. So we'll just go ahead and bring up the debugger. Here we go. And we'll just right-click it and run as administrator. And we can go ahead and open up the crash dump, which we'll find in the Windows folder. And up comes the crash we just created. So you could see that the crash was a stop D1 bug check. most likely caused by myfault.sys, as we know. But what I wanted to do was just quickly look at the event log entries. So I'm going to do that wmitrace command .strdump. That'll show me all the various event logs out there. And the one we're interested in is the system event log, and it happens to be IDC. So we're going to do the bang wmitrace command .event log dump, giving it the ID of C. And that will go ahead and dump out the system event log, those last few events that were recorded in memory. So we can go out and we'll just go back and take a look at the output here. All right. So here's where I issued the command, bang wmitrace.strdump. It gave me the various events logs, and here is the actual one that I dumped out, which is the system event log, as you can see. It tells us header information and then gives us the various events that have been experienced. For example, let's scroll down a little bit and find a meaningful one. Here we go. We've got one recorded by the Microsoft Windows Filter Manager, and it tells us that essentially we've got file IO info that we've unloaded successfully a driver out there, and we've got several other events as well. For example, here's the myfault.sys that got loaded just before the crash. It says a service was installed on the system. So we get these last few events that are stored in RAM in the non-page pool area that got put into the memory dump when we crashed the system. Now let's go ahead and just take a quick look at that ETL trace file. We can take a look at the kernel.etl by just double-clicking on that file, and that'll bring up the Windows Performance Analyzer that we learned about in an earlier module. So you can see the Windows Performance Analyzer is loading the various data. Up comes the thumbnail charts on the left-hand side. Those are the Graph Explorer. So we can literally drill down here and see the computational activity, one of which is the CPU sampled subdata. So I can double-click here, which will bring it up into the analysis pane. And you can see right before the system crashed, something fired up. What was it? It was something called isitme.exe. And then Logman started collecting data. So here we have caught this runaway process in the act of dominating the CPU. Perhaps that's what you were troubleshooting to begin with. So hopefully this gives you a good idea of how to set up a perfmon threshold alert to fire off an action routine from a task to help you troubleshooting an intermittent performance issue.